So this is practice problem 1. So this is our code in JavaScript, and herein we need to tell the big O of this entire code, that is the runtime. In terms of big O, we need to find general, the fuzzy counting. So let's begin with this very one, initializing variables. So we have initialized a equal to 0 and b equals to 0. Clearly this will have a big O of 1, and this also will have a big O of 1, and all over the big O of 1 would be O of 1, right? 2 big of O, basically if you write it in detail, it will become 2 times O of 1. So we eliminate this part because this is basically the constant part, and we just are left. So this part has a big O of 1. That is, it has a constant runtime, or say the time complexity is constant, right? So let's go in here. So here in, let me zoom it. Here in is a for loop. Inside we have initializing variables and all those things. And so basically here are two loops, these are nested loops. So yeah, multi-dimensional loops. So here when we have two loop. The first one, the for loop, starts at I and goes till n. It doesn't reach n. It doesn't reach. It does not. It just iterates one times. At the beginning it would be 0, and it will go till n minus 1. So it's like from 0 to n minus 1 times. So including 0 and n minus 1, we have n times. It runs n times. How many times? It runs n times. How much time? And so similarly goes with this one. Inside this for loop we have another loop, that is another for loop, which is like j equals to 0, and it goes till it never reaches n. By the way, almost n, but never reaches n, and at every iteration 1 is added to j. So it also is similar from 0 to n minus 1. So it will also run n time. Now if we look clearly, if these two were separate for loops, then the big O would have been O of n. But since these two loops are nested inside each other, for that very reason, the O, the number of times the inside statement, which is this one, would run n square times, right? So the big O of this one would be On, and the big O of this one would be On, and the big O of this very statement, which is inside the very core of this for loop, would run n square time. That is O1 times n square times. But by the way, if you take out the entire statements, big O would come out to be as O of n square. Okay, so here in this part fragment we got O1, this fragment we got O of n square. Hopefully this was understood. This very statement will run n square times. So it has a this is an initializing statement, so it has a big O of 1. So this will run O1 times n square times. So if you take out the big O of this, like how many times this very code, this very fragment will run, would be n square times. So the big O turns out to be O(n) square. So all of these things are ignored, and we consider this part. Now the last for loop. So it's initialized at k equal to 0, and it goes still, never reaches n. It iterates one times each iteration, plus 1 is added in each iteration. And so basically this runs similarly n times, and this statement also runs n times. So the big O of this part is n01, that is n times O1, right? Which would be considered as O of 1. But however, the entire code would run n times. So the big O comes out to be O of n. Now this fragment, and the very first fragment has to be added. So adding O1 plus O of n square plus O of n. So we'll cancel out the non-dominating terms. So non-dominating is this, and non-dominating is this. The dominating term here is O of 1. The entire big O of this program turns out to be O(n) square. So time complexity of. So this is another similar question to this practice problem 1. So let's try to solve this. So we'll speed up our process here, so as we know how to solve this, because this is a quite similar question. This part, let a equal to 0 and b equal to 1. This is basically initialization is happening, basically assignment is happening. So where we assign variables to something, that very process becomes that very process takes a time complexity of, it takes a very constant time, as I told you before. So basically it will take big O of 1. So this part is solved, big O of 1. Similarly, this part, so basically as I told you, this it starts from I and it iterates 1 times, every iteration it just adds 1 to I, and it never reaches I, by the way. It just, before reaching I, it just terminates. So this loops exit. So basically this for loops exist. So it's like from 0 to n minus 1, right? So 0 to n minus 1, including 0 and n minus 1, it is how many times? So basically this very loop will run, I'm sorry for that, loop will run O n times, right? Now as we look carefully, we have also, this is basically a nested loop, as I told you. So this will have a similar property like this, because as I told you, j is equal to 0 and j is less than n. Basically j never reaches n, and j iterates j iterates every time by +1. So basically j is equal to j plus 1. So basically j starts with 0 and goes to 2, 3, 4 and goes till n minus 1. So how many times? Similarly 0 to n minus 1 times, right? N minus 1 times. So how many times this loop will run? 0 to n minus 1, including 0 and n minus 1. It is basically n times. It's basically n times. So how many times? O of n, right? Now if we look carefully, this inside, the last for loop inside here has a statement, right? So the effect of both of these for loop will be applied on this last one. So basically let's analyze what kind of a complexity this very statement is producing. It's basically O of 1, because here assignment is happening. Basically A is added to j, basically j is added to A. You know what I mean, right? So basically assignment is happening. All right, so how many times this assignment process will happen? How many times will this loop will this statement execute? So it will happen, as I told you, n square time. Now why? Because since this happens n times and this is inside the for loop, so it must happen n square times. So basically n square times. Now overall time complexity of this very fragment would be O of n square, right? Going further down, so here it has a similar property. K starts to 0 and k every time iterates +1 times. Basically k is equals to k plus 1, and k actually never reaches n. That means it starts from 0 and it goes till basically n minus 1 times. Sorry, I have taken small n here. You should have taken capital N here, by the way. You understand, we can for this very question, let's say n is interchangeable. Small n and capital N are basically same for this very question. All right, to avoid confusion. And yeah, so herein also we have a statement, and big O of this is O of 1. This is basically initialization is happening here, and this one will iterate n times, right? So it iterates n times, so this will also iterate n times. All over the complexity, time complexity would be, the big O should be n, right? Now let's compare this and this together. How do we do that? We basically add them. For comparing, we'll add them and we'll find what is the highest term there. The highest term is to be worshipped and other terms are to be neglected. So O of 1, O of n, biggest term this. So basically the time complexity of this very question goes like square, or say clearing up and square, right? Hopefully it clears your doubt. So this next practice problem, so basically let's name it as practice problem 2. It is kind of different. Why? It is kind of different. So if you are not able to make this straight away after solving the practice problem 1 and the similar question to that, it's not a big deal. It's okay. It's okay to not solve it, because it's kind of quite different, but it doesn't mean that you'll not be able to solve the questions after doing this. Basically these are basically 10 types of questions, and this covers mostly all of the questions which regarding the big O and loops and all. It just covers most of them. So straight away, let's just dive into it. Basically these are good questions to practice on big O. So if you just not able to solve it, it's not a big deal. The thing is, mug it up. Remember it. Just get through it. Have a good practice of it. So he will be good to go. Basically initialization, we'll ignore it. You know what the big O of this is? Basically O of 1. Big O is 1. It doesn't really bring any change in all over time complexity of this algorithm, right? It's just like big O, we don't effing care, right? Hopefully understood. So basically this fragment and this fragment. Now this fragment here, so it would look very easy, right? It would look like, okay, so it's like the past question wherein it was like from, I is from 0 and it never reaches n, and I iterates. Very good. It's like 0 to n minus 1, right? Yeah, n times. Okay, n times. Big O is of n here, of this very loop. But if you look carefully, it's a nested loop. this is a for loop inside a for loop. We'll say, yeah, it doesn't even matter, right? So basically the big O would become O of n square. Now here you go wrong. Just look at it carefully. It's not as simple as it was before. Basically here, this very first loop is very easy. The second loop is very complicated. And this statement, like how many times this statement counts, basically how many times will this very inside statement will execute, you know, that will decide basically the big O of the entire, big O of this entire you know, fragment, right? Or let's say big O of this entire algorithm. So if we clearly look into this, we'll find that j is not dependent on 0. J is not equal to 0. J is basically equal to n, and j is J is also having basically the for loop of this in which there is a variable j is a decrement operator here is also used. And even j should be greater than I. It's not n? No, it's not n, it's I. So basically I, j and n, all of them are, and the number of times this will execute, all are connected. So in order to find how many times this will execute, we need to consider all of them together. So in order to make this, in order to find like what is the pattern of, you know, execution, or how basically let's consider n equal to 5. You can consider n equal to anything, but we have, for convenience, for a small number, we have considered n equals to 5. Now for n equals to 5, we'll declare j, and we'll declare I, and we'll declare count. Count basically means how many times this will execute. You know, since all of these are connected, let's try to find a pattern in this, right? So at n equal to 5, right? Hopefully visible, equal to 5. J equals to 0. This is the first round happening of the loop, and I equals to 0, sorry, and j is equal to how much? 5 to 1, right? 5 to 1, clearly 5 to 1. If n is equals to 5, then since j is equal to 5, right, according to this loop, so j's value will fluctuate from 5 to 1. So how many times will this execute, this very statement inside this, basically this for loop will execute how many times? It will execute 5, 4, 3, 2, 1, basically 5 times. 5, 4, 3, 2, 1. How many times? 5 times. All right. In the second round, second times the loop executing, all of this loop. In the second time, what would happen to I? I would be added plus 1. Basically, I iterates, right? Second time. I was 0. All right, no problem. We were able to solve it. But now I's value has changed. I's value is equals to I plus 1. So I is changed now, right? I plus plus means I is this. I is added 1. So yeah, in the next in the next process, in the next round, I is equals to 1. So herein, if I is equals to 1, then since I is equals to 1, then j's value, j's value should start from 5, you know, and it should go but not reach j, but should not reach I, that is 1. That means it should go till 2. Okay, let's count. 5, 4, 3, 2. How many times this inside loop will execute? The for loop, inside for loop will execute, or this very statement will execute? 4 times. Similarly, in the next round, it's kind of hard, I understand. It's really kind of challenging. Right, it was challenging for me too. I just kind of mug it up, you know. Now, I equals to 2. J will fluctuate from 5 till, now I is equals to 2. So, J will never reach 2. So, it will reach 3. So, J's value will fluctuate from 5 to 3. 5, 4, 3. How many times? 3 times. So you can see a pattern is forming 5, 4, 3, the number of times. We are basically trying to find number of times this very code, this very statement inside the nested for loop will execute. We are just too keen to find that, right? So we'll go from now we'll just set for sure, we'll set I equals to 3. Now this will fluctuate from 5 to 2 because it can never reach, you know, according to the statement itself, the inside for loop statement itself, j can never reach I. J is never reaching I. Since I is equals to 3, so j will never reach 3. It will reach till 2, right? Therefore it will execute 5 till 3. Oh, till 4 basically. 5 and 4. So how many times? 2 times. Now when we'll set I equals to 4, we'll from 5 to 5. Now how many times will this execute? This 1 time. So यहाँ से लेके till here we have basically found a pattern. The pattern is 5, 4, 3, 2, 1. Right. So you will set it into a series. This for the series for n. The series for n would be like series for n for this one be like n plus n minus 1 plus n minus 2 plus dot 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 till 1, right? 5 4 3 2 1. If we add them together, we'll be able to find how many times this will be executing. This inside one would be executing, right? So basically it would come out to be n into n plus 1 by 2. We'll solve this further somewhere else. Let's try to solve it here. So n into n plus 1 by 2 will become n by 2, sorry, it will become n square upon n by 2. This will ignore the non-dominating term, and furthermore we will remove this constant from this, so we'll be left with n square. So we found n. We found how many times this will execute. This will execute n square times. Big O of 1 n square times. Therefore all over big O becomes O of n square, right? And the entire, for this entire loop, the big O is, since this has no contribution at all into the big O, is simply O square. This is a similar question to question problem, practice problem 2. So we'll just do it very quickly. First part is initialization. Basically the initialization will have basically no impact on this big O of this part. So basically let's say it O of 1, let's try it or not, doesn't even matter. For this part, this first for loop start from 0 and goes till n minus 1. So start from 0 and goes till n minus 1. This basically this will run n times. Now this is not the case for the inside for loop. Basically the inside for loop will run, we don't know how many times. So basically that is what we need to find. So basically inside for loop starts from n and it basically decrements, right? And inside for loop will always be greater than I, always will be greater than I. So basically it will never reach I, always be greater than I. Alright, so basically I will never be equal to j, and inside this is our statement, inside our for loop statement. So how many times this will execute, how many times, I mean like how many times, that is what we need to find. So if we find how many times this will execute, we will be able to find how many times basically, if you're able to find how many times this inside for loop, the nested inside the multidimensional for loop, this very inside for loop will execute, we will be able to find how many times this statement will execute. Now why this is so important to find the inside this statement's number of times it will execute, because this will decide the all over time complexity of this fragment, this basically fragment of code, the snippet of code of, so yeah. So it's quite similar to question number practice question 2. So let's first of all declare I, j and count to ease our process. So now how to do this? Let's set n equals to 5. So n equals to 5 and n becomes 5 as well here. And yeah, and we should always remember j should always be greater than I, and it should not ever reach I. So let's start I. So let's start with I. N equals to 5. I equals to 0. And now j's value will fluctuate from 5 till 1. So how much count? 1 2 3 4 5. So how many times? 5 times. Okay, 5 times the count. Now I becomes 1 now, because this is the second round. In second round I is incremented. I plus plus basically means I 1 plus I plus 1. So basically I will be iterated by 1. So I is incremented by 1. So now j's value will fluctuate from 5 till 2. Why? Because it can never reach 1. So it should go till 2. And how do we know that? Because for loop for with a j as a variable clearly tells that j is always greater than I, never reaches I, never equal to I. Alright, so how many times? 5, 4, 3, 2. How many times? Basically 4 times. So basically go for I equals to 2 in the next round, and 5 goes till basically 3. 5, 4, 3. How many times? 3 times. Now I equals to 3. 5 goes to 4 times. How many times? 1, 5 and 4. How many times? 2 times. Now at I equals to 4. How many times? 5 till 5 to 5. So basically j's value is getting very very closer to itself. 5 equals to 5. So closer to basically n. So at j I equals to 4, we get how many times this statement getting executed? It's getting 1 time executed. So as you can clearly tell, there is a trend in this 5 4 3 2 1. So basically n, first of all it's n, then it goes till like n minus 1, and it's just like similarly this trend is being followed here. So basically the series for n would be n into n plus 1 by 2. Alright, so how do we know that? Basically 5. And what is 4? There is n minus 1. What is 3? N minus 2. What is 2? N minus 3. Dot 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 till 1. So basically the pattern for n as a series would give us n into n plus 1 by 2, n square upon n by 2. We remove this term, this is non-dominating term, and n square upon 2, we remove this as well, so basically n square. So this statement will execute n square times, or say this for loop, inside for loop will execute n square times. Basically all over complexity of this snippet of code becomes O of 1, ignore that, plus O of n square. So which is the dominating term? For sure this. So basically big O of this very snippet of code becomes O n square. This is practice problem 3, and this is quite a straightforward question, basically straightforward code. So this is a snippet of JavaScript code here, and it's quite straightforward. Why do I say straightforward? Because this is basically clearly very much visible. The for loops here are clearly nested. Now what is the easy thing about this nested for loop is that all of these for loops variables are interdependent of each other. Basically I is dependent on n, I is equals to 1, and you can see I just keeps iterating till it reaches n. Similarly goes with the inside for loop, similar property, and similarly with the last for loop. So let's see, the very first for loop will iterate from 1 till n. How many times? Let's say how many times? It's basically n times. Let's say n times. And here it also is from 1 to n. It also goes for n times, and the last one also n times. So now the very important question, this very statement inside the nested for loop will basically decide what will be the overall complexity of this snippet of code. So basically combining all of these, basically this will have a complexity of 1, and this will become n cube, basically times n cube times. Why? Because all of these loops are nested. So the overall complexity after combining becomes O, big O of n cube. So it's not linear, it's not constant, it's n cube. So runtime is clearly bad. This is a very bad code basically, right? So it will take really, basically as n grows, the time complexity of this algorithm also grows drastically, and it's bad. It falls under the very bad. So basically this is the graph, and this is of, let's say, O of 1, and this is of n, say this is of n, and this is of n cube. So n cube is at very bad. Till here it's fair. N cube falls in a very bad range of time complexity. So this is practice problem 4, and this is by far the most interesting one, to be honest. And to be honest, it's really interesting, and it's kind of easy, and yeah, by far more is the easiest and very interesting one. And it's kind of tricky as well. It's a combination of all of this. So basically the question goes like, which of the following have the same time complexity as O of n? Basically means which of the following has a linear time consistency, like 1:1, right? So let's read the first one. O n plus p, where p, right? So can you tell, so you can clearly tell that, right? We can clearly tell that p is a very small value. And how can we tell that? Basically it says p is smaller than even 9 n by 9th of 1 by 9th of n. Basically if this is 9, so it's like 1 by 9, this part, this is p, and this is entire n, right? So it says like p is that small. So if p is that small, so we can clearly ignore this part. The big of O, big O, basically the big O complexity becomes as n. It's valid 1. It's come 2 here in. We can write this as, we can simply cut k, or we can simply write k as k0 comes out. We can ignore this part, having it as O9n. Even we can ignore the constant multiply, right? The factor come out to be n. 9 is not that big of a number, ignore it. O of n comes out to be O of n. Third one, 8 log n. 8 log, now 8 log n. So 8 log n is a really again a small value, right? Log n again a, right, is a small value. 8 times log n is again a small value. Basically log base is a non-dominating term as compared to n, and even if it's multiplied with 8, it makes no difference. Basically the entire term is terminated, and we consider just O of, hopefully this was understood, right? So O of n again. Now this one is kind of tricky. Herein, where m and n both are input. So yeah, it doesn't mean that you need to cut this part, and you're gonna cut this part and would be like O of n. No, or you can cut this n and m square as our time complexity, O big m square. No, why not? Because these both are input. Instead of let's change this question and write it as, let's say, length, length plus n plus m square, right? In this case, if it was described like length is greater than n is greater than m square, so the big O would come out to be length, yeah, simply O of L, right? But in this case, it's written none of these cases are specified. It's just given m and r. M and N, N, M, and N, M, M are both input. So basically the big O comes out to be O and square. So this is only the rare case wherein the big O is not N. In all of the N case, N plus M square. Why M square is not terminated? Basically, we really don't know whether N is bigger or M is bigger or M square. No, we're gonna put them together. Right. Hopefully this answers the question. Another very interesting question. So another very interesting case, if I be specific. This is practice problem 6. I'm sorry, it's practice problem 5. So herein we will learn about what is big O's, what actually big O basically means. I mean, like what does it mean? Like why big O? So basically, if you look carefully here, there's if statement and else statement. This if else statement. So this first part is if, and the second brush part is else statement. So basically, as we clearly know that if statement would be like if it is true, then console log x is less than 7, and this goes like else. Otherwise, if x is not less than 7, print, basically execute this very damn loop. All right, so here comparison operator happening, right? Comparison operator happening. So basically O of 1, right? So basically it will also run 1 times. So basically this first part, this first fragment would be big O of 1 clearly. Now the else part would only execute if something goes wrong, or if if it's, let's say 8 bigger than 7. So in that case else will execute. So what I'm trying, the point I'm trying to make is that the worst case situation would be that the else statement would execute, right? So we have two cases, right? So either this if statement will execute, either else statement will execute. So we'll take in the worst case that can happen. So basically whatever. So here in if you can clearly say that I starts from 1 and it goes till n minus 1. So n starts from 1 to n minus 1 clearly, right? So, or let's say yeah, till n minus 1. How many? Basically big O is 1, right? So how many times will this execute? Oh, I'm sorry, big O is n, right? How many times? O into 1 times n times. So this becomes all over becomes O of n, right? So now comparing both sides, comparing this and this. So basically we have O of 1 and O of n. Terminate the non-dominating big O, left with n. So time complexity is linear. The point was, in the worst case situation, O of n can happen. Basically else statement will, if else, chances are that it would not become a worst case situation, but if it does, else will execute. If else executes, O of n. But if it goes right, the big O is O of 1. But what we would consider O of n, the worst case situation. This was what I was trying. So this is another very interesting question. This question is basically based on log. How log? Basically big O in terms of log. So how do we start? So it's not as simple as it. So okay, by the way, before moving forward, let me explain what this means. N into equal to 2 on n starting means x is equals to x times start. So what does it mean? So x starts from a 1 and it is always going to be smaller than n, and if it's somehow bigger than n, then the loop will stop. In each iteration x is multiplied by 2. So we can frame it like I. So basically this is a very typical question of log in terms of big O in terms of log. So how do I solve this? Is in first iteration, what would happen? 1 is multiplied with, what do we get? We get 2, right? Now this 2 will get multiplied again by 2, becomes 2. 1 times 2 becomes 2 square. Now this 2 square would in the another round would be multiplied by 2 and would gives 2's cube, right? Quite clear. So it keeps happening again. 4 so let's say 2 to the power k is that value which is greater than n. That means wherein the loop actually exits. Why? Because 2 to the power k is bigger than n. Shouldn't be bigger than. So basically this is the number where the loop exits. Yeah, lips having. So whatever. So in this very case, let's say 2k is equals to n in the worst case, and we just basically multiply log both sides. So k comes out, and basically log base with base 2 becomes log. So log 2 base 2 would become 1, and this will give log base n. Eliminate n. These are binary logarithms in programming and coding log. So whatever. So the k's value is log n. So basically this very statement console.log state would execute log n time, right? Log n time. So basically the all over big O would becomes O log n. Yeah, oh sorry, small n. In our case that is small. Hopefully it was clear. It's very interesting question. So I will even teach you a very important trick for this. So basically if something like this is shown, wherein this in a loop we are given x is equal to x into 2, whether it is 3 into 3 or whether into 4, so it will have a great impact on the log. What do I mean by that? If it is 2, then we got log 2 base n, right? If it is 3, then we have O log 3 base n. Okay. If it is 4, then we have log 4 base n. Similarly like that. So yeah. And the funny thing is, I'll teach you next, would be like, even if there is divide here, so that will be no change in the big O. The big O would be, if it is divide equal to 2, the big O would be log base 2n. If divide equal to 3, log 3 base n. There will be no change in the big O, hopefully. So basically we'll not go deep into solve this question. We'll go deep into how to solve this question when we will be dealing with big O of logarithmic big O. The video basically dedicated on logarithm, logarithms in complex, entirely based on that. In this video talk about how to actually find the big O of such a thing. So basically here, so first part is initialization. So it's one. Second part is also initialization. One herein is a loop. Third segment is kind of different. So I is greater than O. Relation I is greater than relation A is added to I, and I while. So basically is a while I is equals I divided to, right? So since it's divided by 2, so it will follow a basic pattern. It'll just basically follow a pattern be executed. It is logs 2 and time, right? While loop it execute time O and log. We can ignore not. Hopefully, or another way of solving this is by taking n as some value and gradually realizing that keeps dividing itself by 2, and later on concluding it has log n time. So this is the 9th practice problem. And herein we have two snippets JavaScript. Why this question is kind of interesting, because let me tell you, this question really marks the difference between, like, what is more important, root n is important or n, it just tells the difference. Like these both are written almost in the same way, just taking square root on one side makes the default, how changes the time complexity, the runtime of this algorithm. So let's basically just the first code in here fully, right? Fully visible. All right, so function is a prime n. So basically I is equals to 2 and I smaller than, basically I is from 2 to n minus, right? So how many times will it run? N minus 2 times, right? 2 times, right? Times will it run minus 2 times. This here is initialization, all one change done false. Now this part basically this one here is O of 1, right? O of 1, but it will be executed how many times? N minus 2 times, okay, times, right? So the overall time, so we can ignore this minus 2 thing, we can ignore, and we'll just consider n times. All right, the big O becomes O of on the left. Now let's read this on the right side. The same basically is a prime is a function, basically checks if n, the given number, the input, prime or not. Similarly prime or not, this also code does the same thing, but we are here to judge the time complexity. The time complexity is on complexity here. So similarly function is a prime, and let's name alright, we don't have a problem with that. So I starts with 2 and it goes till square root of, goes to equal to square root, right? All right, 2 to square root of n, square root of n. No, it's not equal to 2 root minus 1 time. All right, so and similar to this and this, both are similar. So O of 1 function, this if loop would be having a big O of 1. This part, however, O of 1, though it will be multiplied how many times? Okay, by the way, this for loop, how many times will it execute? Root n minus 2 times, or let's say simply root n times. This will be times root n, and all over complexity of this function would clearly now we are very mature now. So root n and complete whole n. So which is gonna perform better? For sure the right hand side. Why? Because root n is a smaller value, bigger value. Smaller the big n is, the better for our runtime, the better time complex, better the big O. So this is basically the last practice problem we are practicing, and herein you'll be shocked. So which of the following option does not have a time complexity of O n square, right? So the following doesn't have a quadratic time complexity. So herein, as we know the rules, we can cut this one, because this is a constant term, and you would be moving forward to cut this, but stop, you should stop. The time complexity of this is O n squared. It would be like, damn, how it's just n here, it's just a constant. No, look carefully, it's just not any other constant. So much big of a constant. The chances are it's even equivalent to even n. So in that case, it becomes n square. We are considering the worst possible out for that case square. Hopefully now herein what should be it? 1.5. What should be the time complexity of? Okay, it would be n square, and you'd be like, oh, why? So basically, why can't it be 1.95 or 1.9 n to the power? This is because we can only approximate upward values. We can just approximate upwards, not downward. Downward is not basically O square is the complexity. Again, now this one, this is kind of cool. So it's just need some math. By 2 up, 3 2 up and down, power 5 by, that's gonna just be, let's keep solving this. Let's keep solve 5. Approximated it to be n cube. So big O of this one turns out to be O cube, and which is not O n square. So I think C is our option. And in D, as I told you, it's too much big of a number, so we'll consider it as n. So we n times n over the n square. Big O would be O n square. Hopefully, basically bigger powers are to be considered n. Remember that rule. And we are all set to go. And this is how we end this practice problem based on JavaScript, based on time complexity. Easy question. It contained some logarithmic questions as well, some loops, for loop, if, while loops, and everything. Let's keep practicing, let's keep getting better. Okay, see you in the next video. The next video is most probably based on logarithmic, so we'll focus more on those log values we used to get as in time after solving the for loop or while loop. So yeah, we'll focus on that. Till now, bye bye.